Welcome. Let's take a look at a couple of examples of using the substitution technique for integrating indefinite integrals. The first example we have here is the integral of 8x cubed times the quantity 2x to the fourth minus 7 raised to the fourth power dx. Now, in theory, because this is raised to the fourth power, we could go ahead and multiply the 2x to the fourth plus 7 by itself 4 times, then multiply by 8x cubed. However, that is very time-consuming, tedious process, and the technique of substitution makes this much more feasible. So when we do the substitution process, we look for instances of composition of functions. And then, based on instances of composition of functions, we look for elements of the integrand that might be a derivative of something else. So when I look at this integrand, I see that I have 2x to the fourth plus 7 as the argument of a function to the fourth power. So I see a composition of functions here where 2x to the fourth plus 7 is inside base to the fourth power. Also, I notice that if I were to take the derivative of this 2x to the fourth plus 7, I would end up with 8x cubed. So let's go ahead and let's let our substitute, the variable we're going to replace x with, we'll replace x with u. So we're going to let u equal that inside, that argument, that 2x to the fourth plus 7. If I do that, then the differential for u is u prime of x dx. Or in this case, our differential for u is 8x cubed dx. So what I'm going to do is I'm going to use the commutative property of multiplication to rewrite my integral a little bit here. And I'm going to put the quantity 2x to the fourth plus 7 raised to the fourth power first, times, and then 8x cubed dx second. And now what I can see is that I have 8x cubed dx, and I can replace that with du. So this is going to be replaced by du. And then I notice that I've got this u as 2x to the fourth plus 7. So I'm going to replace 2x to the fourth plus 7 raised to the fourth power. That's going to be replaced by u to the fourth power. So my new indefinite integral is simply u to the fourth power du. And this is a much simpler integral to integrate. The antiderivative here being u to the fifth power over 5 plus our constant of integration. Now we're not quite done. The original integral was in terms of x, so we need to replace u with the function that we defined it with. And so we would end up with the quantity 2x to the fourth plus 7 raised to the fifth power divided by 5 plus c. And here we have the antiderivative of the original integral. Let's take a look at this second example. We're going to use kind of the same perspective here. We're going to look for composition of functions and elements of the integrand that are derivatives of other elements. So what I notice in our second integral, the integral of x cubed times the quantity 5x to the fourth minus 7 raised to the 7th power dx, is that I have a composition here where I have something raised to the 7th power. And the argument there is 5x to the fourth minus 2. So let's be hopeful. Let's hope that we can let u equal that argument, that 5x to the fourth minus 2. And if we do that, then our differential du, which as a reminder is u prime of x dx, our differential is 20x cubed dx. Now, as we look at our integral here, we can see that basically this 5x to the fourth minus 2 raised to the 7th power can be replaced by u to the 7th. Notice though that when I look at my differential, I've got x cubed and dx, but I don't have 20. Now, that's easy enough to fix. Let's consider the idea of multiplying our integral by 20 over 20. And then let's go ahead and separate that 20 over 20. Let's think of that as 1 over 20 times 20 times, and then I'm going to put my 7th power next. So 5x to the fourth minus 2 to the 7th power, and then I have an x cubed dx. And then I need the 20, this 20, to be part of my differential du. This 1 over 20 I don't need as part of my differential. So what I'm going to do is I'm going to bring it outside the integral like a coefficient or a constant. So 1 over 20. Then I'm going to rewrite this as 5x to the fourth minus 2 raised to the 7th power. And then I'm going to use the commutative property of multiplication to rewrite this as 20x cubed dx. Now in this form, I can replace the 20x cubed dx with du. I can replace the quantity 5x to the fourth minus 2 raised to the 7th power by u to the 7th. And now I have a new integral that is written entirely in this new variable u. And this new variable u is going to make it easier to find the antiderivative. So we have 1 over 20 times the antiderivative of u to the 7th du. And that becomes 1 over 20. The antiderivative of u to the 7th would be u to the 8th over 8 plus c. And now if I multiply those denominators, I get u to the 8th over 160 plus c. And now we're not quite done. Remember that we do have to replace u with the original definition of u, the 5x to the fourth minus 2. So our final answer becomes the quantity 5x to the fourth minus 2 raised to the 8th power over 160 plus c. And there's our antiderivative. I hope you find this helpful.